My name is James Black, and today we're going to be talking more about blockchain design. This is from a high level. I've been looking at various documents lately, white papers on what people are trying to do with blockchain, and I realize that a lot of people really don't understand what blockchain is. So it's time to talk about it a bit. Okay, so what is blockchain? Common definition is, you can read it on the screen, but basically if you have 3 or 4 accounting ledgers, and each row is or Excel spreadsheet. Each row is we'll call a block. And then you somehow tie that to the previous line so that I can't make any changes in the previous line without changing the line before that. Then all of my blocks are chained. I have a blockchain. So it's a distributed ledger that can't be changed. That's basically it. It's a pretty simple concept. So what are some obstacles? Well, with any new technology, there's a few obstacles. One is manufacturing resource planning long ago. Manufacturers would do is they would have people go into a room once a month, and they would figure out, they'd spend a week looking at, well, what do they need to order for the next month? They need to have raw material coming in for their factories. Then they got mini computers. Mini computers could do that overnight. So there was no need to do this once a week thing, but they kept doing the once a week thing because that was their process. Just because they got the mini computers didn't mean, just because they were using new technology didn't mean they actually changed the process. That's a problem. We need to, this is why big data has to a large extent failed, I think, because people weren't changing their processes. So if you're going to approach something like blockchain, you have to look at what are we currently doing, and because of the limitations we have now or how everything works, and what can we do with this new based on this new technology. Let's change our rules, our processes. That's a big obstacle, is just the mental leap that people have to make. So we'll go through a little scenario. My brother and I had started a business. We were in California, and California is all about eating healthy. So we decided to call it Hail Kale. It was all kale products. So we had kale smoothies, we would have kale burgers, we would have kale tortillas, that kind of like tortillas to roll your breakfast burrito in. All kale all the time. The first store did really well. So we opened up a second store. So I ran the first store, my brother ran the second store. Because we trusted each other, we didn't have any problem, because we had explicit trust. Then we started opening franchises. Okay, so, because amazingly, our friends didn't want to participate necessarily, but other people did, so we started to open these different franchises. Problem is that once you start opening these other stores, well, we don't necessarily know if they're being completely honest with us. So what we did is we had to start auditing. So we'd send people to go in. They would look at, their books, make certain that everything was correct. And you can see from the document that you can actually have a whole lot of different, you could be auditing on sales, purchases, payroll, inventory. This all goes into a general ledger, so then you can look at how everything works. It gets really complicated. Takes a lot of time for the franchisee, we're paying people to go out and do this. It's a pain, it's expensive. And it may not actually catch everything because they may have 2 sets of books, we don't know. So we also had, I wonder if I didn't move this over far enough. So we also had, there's different kinds of, so this is just showing other data that you would need from a restaurant. So you have your payroll, you have your different accounts, So you end up having lots of different spreadsheets that we'd have to be looking at. It gets complicated. So our process was pretty simple. The credit card processing, we didn't want that to be centralized with us. So you swipe your card at the restaurant. They would have some company that they would do work with to do the actual credit card processing, and then but the headquarters, we wanted to make sure that we ordered everything, because if we can order in bulk, so we can order all the spoons, make certain they're all standard, make certain that and we can get lower prices because we're doing bulk. We also wanted to have a payroll breakdown, mainly because we want to make certain that people weren't being cheated. So you want to make certain that women and men are being paid the same, are comparably the same. You want to make certain that some people are not being overworked and some people are being underworked. A lot of different reports that we wanted to do just to see what's going on with our company, the health of our company. So we had these different processes in place. But if you audit anyone, that means there's a trust issue. If there's any government regulators in your business, there's a trust issue. We have trust. If we have trust issues, we have to validate. We have to verify. There's all kinds of different terms you can come up with, but basically it just means I don't completely trust you, so I'm just going to come in and make sure that what you're telling me is true. That means you need a blockchain. Okay, so there's different kinds of ways to look at, there's different types of blockchain. So for example, how do you get access to the network? Oh, by the way, this slide share at the bottom, really a good slide deck. I would recommend it. I think they did a great job. But basically, you have to look at, well, what kind of blockchain do I need now? Do I want something that, so you can go through different flowcharts and you could look at how fast do I want it to be, because a private blockchain is going to be faster than a public blockchain, because if I only have 100 nodes that have to come to agreement, or I have 1,000,000, which one's going to be faster? You can have permission blockchain, so you could say, okay, well, only people that have certain rights can do these actions. And then you have, there's different ways to validate. So you basically first have to figure out what kind of blockchain do I want. And what we're basically looking at is we had a centralized approach here. So we had all the data going into our business. Okay, and so then what you could do if you're larger, you could say, okay, well, I'll tell you what, we don't want to have all this going to headquarters, so we'll have some regional offices, and they'll actually collect the data, and then they'll send us what they have, so we'll trusting the regional managers more. Not really, but in theory, you could do that. Then you have a distributed system, and then you could say, okay, well, we're going to make each region is going to be its own headquarters. So they're more decentralized. And then you eventually come to a peer-to-peer. So in the decentralized, there is no managing group. Everyone, and in peer-to-peer, everyone's just working together. I think we're heading more to peer-to-peer with blockchain. So I'm trying to explain a lot of terms at the moment to help people out. So we have a smart contract. Basically, a smart contract is an application that is code that runs on the blockchain. So you buy some kale from my restaurant. That goes into the blockchain. I then have an application that runs that says that might subtract how much inventory you have. So I now know how much you currently have. So, and it's in an application that everyone on the blockchain can see. So the idea is to try and be more transparent, to try and be more open. And you can also, though, have where, for example, You can make it very binding. So, for example, you work for me a certain number of hours. So you put in your time into a timesheet. You put it on the blockchain. I then approve those hours. You get paid. That could all be done through the blockchain. You can get rid of a lot of extra paperwork by just doing that. And for example, in Tennessee, they're trying to make it more binding than it currently is, but eventually it'll become legally binding. I think a big part of that, though, is we're going to need to have some way to know who you really are. So, but the basic idea is that all these people in the middle, you get rid of, and you can just have where the 2 parties involved or the 5 parties involved in the action are the only ones that have to do anything, then they get the information. So that's what a smart contract is. Okay, so like here's a nice chart as to do you need a blockchain? And so do you need a store state? So if there's nothing you ever need to really store, then you don't need a blockchain. Is there multiple people that are going to be saving data to your database? So there's these different ideas. So you can have permissionless, public permissioned, and all that. But basically, this one are all writers trusted. If it's software, it's not going to be trusted. If it's not a family member, it's probably not going to be trusted. So it becomes a little trickier to say yes or no on some of these. But you can go through different flow charts that you can find and just see which one do you want to use. So what we did was we went with a private blockchain that was permissioned, and we used it to link all of our stores. So we not only linked the stores to the headquarters, but also to the bank. Obviously the bank would, because all the money flowed through the bank, so it just helped to have the bank be part of the blockchain. So we had all their wages, their hours and position were entered, all the different information about items being sold or thrown out was entered, and then that way we could see what's happening in all the stores and the bank could. But what we actually did was we encrypted all the data because Store 4 didn't want Store 1 to know what they did. So it was actually encrypted, and I'll be getting into more about Shamir's secret sharing in a bit. But we made it to where we could see it, and Store 1 could see it, but Store 4, all they saw was encrypted data. But there was also ways that they could still run some analytics, even on the encrypted data, to get an idea as to how are they doing compared to everyone else. And then the bank could see some of the information that applied to them. So they didn't need to see when an item was sold or thrown out. They needed to see what the wages were. So they had a way to be able to do that. So we had all this information, but certain people could see certain things, even though everyone could see the entire ledger. But we realized very quickly that that wasn't enough. Oh. I forgot to correct this text. But basically what we realized is that we also, really to make this correct, we want to make certain that we didn't run into any illegal laws, any legal problems. So we would have our employment. Ideally, we need an employment blockchain. We don't have one. We didn't use one. It doesn't exist. But ideally, all the states and the federal government should have a separate blockchain that just has, so Billy Bob down the street, he would be in this blockchain, so he would be uniquely identified. So I could say, is he allowed to work in this country and stuff like that, and it would be in this blockchain. There would be some sort of a group that's, I call it a connector, that would, all they really do is tie this blockchain and this blockchain. They serve as kind of an interface, because we don't want to have every store be in all these, because then it gets to be too big. So to keep the numbers down, you have a way to be able to say, okay, well, can you just share with me, here's what I need to know, can you just tell me yes or no? And so it has to be someone that's trusted. Same thing with vendors. We want to make certain that they're actually legit. So ideally, we need to have some sort of a way to know that. So we'll end up over time having a lot of different blockchains working together. Okay. So then we said, that was working really well. We were really happy. We decided to have a reward program. So we decided to go with the Hail Kale currency, HKK, which we called Hulk, just because it sounded cool. We have a little muscular guy on the one end of it. It was pretty cool. But each coin was only valid for 1 month, because after a month, the head of Kale went bad, so that coin was no longer good. The coin was actually based on what we got from the farmers. So the farmers would say, well, here we're selling you 100 heads of kale, so now we have 100 coins available. People could then bid on the coins, they could buy them, and then they could use it as currency. So you could buy them early. You could gift your coins to someone. You could say, you really need some kale. Here's a coin. You could also do exchanges, though. So you could say 3 hulks are worth 1 gallon of milk. Milk, interlocal coin, milk. And we know how to do this. We know how to do these exchanges. And the bank could easily do the exchange. Because they could say, okay, well, I'll buy the milk here. I have the kale here. We'll just do the exchange. It's all good. That's something that people have been doing for a really long time. And then we decide to expand it. So some vendors will take the coin. So you could go to, my stores was able to give it to, pay for some of the products with our coin, and the vendors took it. We made a deal with a fitness center, and they allowed people to come in and buy merchandise with this coin. And again, the coin, because it was tied to something physical, it could be exchanged for money at a bank. So we still had a way. So this coin was actually useful to, besides to buy kale. Then we come to virtual currency. So virtual currency isn't really backed by anything real. A lot of times they have a limited supply. They'll sit there and say, we're going to do a initial coin offering, ICO, and we're going to sell 1 billion coins. And then you could sit there and you could bid on them. If it's really popular ICO, they might sell it for a certain amount. It might get, by the time you're done, by the time you get around to doing it, might be worth a lot more. I see this as a pyramid scheme, mainly because of the limited supply and the price fluctuation. So we'll get in that in a bit. So for example, let's say let's look for other uses for blockchains. We want to do hurricane insurance. So you would sit there and the user would know how much they need to insure their house for. They know their address. So what they're going to do is they're going to encrypt it with something called a homomorphic key. Homomorphic key encryption is a neat concept. If I could do math operations on the encrypted data, and it's as though I was doing it without it being encrypted. So I don't actually know what the numbers are. I just know I can do math on them. The user creates a random ID that's unique, and then they take their data, so they take this information here, and they put it on the blockchain. All the insurance companies that are attached to the blockchain will get the data. They can pull the data off. They can analyze it with their machine learning tools, and then they can put the rate back on. So they put on the random ID. They say, here's what our rate would be. So everyone could see that what the rate is, for that random ID, but they have no idea what the numbers actually are for, or who that person is. And then you just look up all the results by your ID that you put on, and you select the best company, and now you have your hurricane insurance. That's kind of how a blockchain would work. For this particular need, that would actually be exactly how it would work. Okay, so now we're getting into this idea about data. Data is everywhere. You go on Facebook. Facebook is free because they're actually selling your data to marketers. I go to a website. I looked at Amazon. I looked at something on Amazon. I went to a website. I see items related to what I looked at on Amazon on that site. So Amazon had sold my information to someone else, to a advertising company, and then I'm seeing those ads. Problem with this is when you do this around Christmas, then kids could see what you've been looking at. I'm not a big fan of that. So we want to own our data. Data is oil. It's like what oil was. It's a valuable commodity. I think everyone should own their own data. So if I go look at Amazon and if Amazon wants to sell it to someone, I should be able to give my permission because I may not want to be associated with this shady company, with some shady advertiser because I don't agree with them. So I want to be able to have some sort of veto power. It's my data, and I should be able to get some money from that. The advertiser should have to pay me a little bit because they're going to be using my data and doing stuff with it to try and improve their advertising. And everything can be done this way. You have your healthcare, your web activity, your financial information. You should own all your data. You make a song, you should not only control who gets it, but for example, if you're listening to my song, you pay a certain amount. But if that song ends up in a movie, they should have paid me a lot more money. If it ended up in an ad, more than if you had listened to it, but less than the movie. So based on how it's being used would depend on how much I get back. We should be able to do that. So you have some different risks and concerns. So I send my information. You buy a house. You send all kinds of information to the mortgage company. How do we know how they're going to use it? Do we trust them? How do you do analytics on sensitive information? So, for example, on the mortgage. I want them to be able to do analytics, but I don't want to send all this data to all these different mortgage companies. I would rather have that be encrypted, have them do their analytics and tell me the rate, and then once we are in agreement that I could give them the information if they need it. Then you also have the fact that some information is owned by more than one person. So, for example, you have a photo of 5 people. All 5 of them should have to agree before that could be used in some sort of an ad campaign because someone might be against what the ad is for and they don't want to be associated with it. So you should have a way to be able to do that. Okay, so then we have ways to protect data. A lot of people are familiar with public key encryption. Public key works out really well when you have more control over what you have a small number of people and there's a little bit more trust. So like in a private blockchain, there's probably going to be more trust. Not in my franchise example, we couldn't use public encryption. But basically what it is you have a special key for a door. This is your public key. You open the door with this special key. It'll open this door. But it can't lock the door. You have to use the private key. So anyone can open this door, but should probably be reversed. So anyone could lock the door, only one key could unlock it. So with public-private encryption, one person can encrypt, only that person could decrypt. Or that person can encrypt, And everyone can know that that person had to have encrypted it because they can all decrypt it with the key. So that's what these are good for. But what's more important here is Shamir secret sharing. So if you take a line, I have a piece of data that's just one number, the slope of the line. So I don't have to tell people what the slope is. I could tell you what one point on the line is. I could tell someone else what another point on the line is. And between those two, they can figure out what the slope is. So for someone else, I give them different numbers, and they can still figure it out. So I can split this key up. In this case, for a line, I could give it to 5 different people. Any 2 of them get together, they can decrypt the data. They can know what the slope is. So you can make it a lot more complex. So think about lines going through multiple dimensions or however you want to envision it. But basically, you could take a key, a code, a password, we'll say, and you can split it up into 5 pieces and just say, well, if any 4 of them get together, they can know what the password is, they can get into that site. That's Shamir secret sharing. That's pretty important here because that means that not everyone has to always be online or available to be able to do these actions. So, for example, if I have healthcare, my doctor wants to see a test that I had done. I could make the request. At some point, the blockchain will tell me the request was made. The doctor made the request. I could approve it, or my doctor could approve it. Between us and the blockchain, it could be encrypted and then sent to my doctor. So that way he could see it, but my doctor and I don't both have to agree on it. Because my doctor might have been playing golf. And so why should my doctor be slowed down because the other doctor was playing golf? So that's what Shamir secret sharing is really an important part now. Okay, so then we have the evolution of insurance. So basically, insurance is you're paying money to someone on the possibility that something else might happen. And you don't want to have to pay for that something else. So, for example, these radio stations, knew there was a word for them. They have, if someone can guess certain numbers, or if you have a certain numbers on your dollar bill, you win $1 million. Well, they don't actually want to pay out $1 million. So they'll go to an insurance company and they'll say, okay, here's the kind of stuff I want to do. They will say, okay, fine, so here's what you'll pay for your insurance premium. And then should someone have that and you have to pay out the $1 million, we'll pay it for you. So they're expecting that given that you're going to be paying this, let's say you're going to be doing this every month. So they're kind of gambling that it's not going to happen, and you're kind of gambling it's going to happen, so you'd rather pay a smaller amount and get the bigger amount. So we've seen insurance change over the centuries, but now we're looking at, can blockchain take it over? Can we take insurance companies out of the picture completely? Can we go to peer-to-peer insurance? I'll be talking about that more so in the next video than in this video. It's just that a lot of this is to try and get you to think, to try and understand what is blockchain, and to have more understanding of the concepts is what I'm trying to do here. But let's look at, I made a statement about pyramid schemes before. So let's look at a stadium. So we have, this is one block, this is a block, this is a block of seats, this is a block of seats. So we sit there and say, okay, well, we're going to break this up into bigger chunks. And we're going to our friends, we're going to sell they're going to bill by each block. So someone bought sections 313 to 322. And then, now what they're going to do is they're going to say, well, each of these little blocks has 10 rows and 15 seats per row. So they have 150 seats. But what they're going to do is they're going to say, you know, I don't want to be responsible for trying to sell all of these. So what I want to do is I'm going to sell each of these. So I paid a certain amount for this, paid $1,000. I sell each of these for $150. Okay. So now I've made then, that means I've made $1,500 profit. Or maybe not. 1, 2, 3, 4, 5, 6, 7, 8. Yeah. So I sold for $150. So $1,500, I made $500 profit. Now the people that are buying this, that was $150 that they paid for this block. So they say, okay, well, it's 10 rows. I need to at least sell it for 15. I'm going to sell it for 20. And then I'm going to get my money back. And then the people that bought each row can then sell each seat. And then people that bought the seat could then do a timeshare. And they could say, okay, well, there's 20 different shows in the stadium, so we could have potentially 20 different people that could actually use that seat during the year. How much money you can make is based on when you got in. So the guy that got in here, he could make a lot more percentage-wise than the person who is paying for the timeshare, because I timeshared my seat. I can't make it to that show, so I'm going to sell my time for that one show for that year to someone else. So I can make a much smaller amount than the early investors. And all of these prices, by the way, were actually set by auction. So, how much I paid for this is different than how much was paid for this or down here. So everything was done by auction, so the prices all fluctuated. So how does a pyramid scheme work? You can look at the image, but basically the early investors make the most, and then you're diluting the value of each seat over time, because as you keep on breaking it down into smaller chunks, everything's becoming worth less than the larger amount. So to me, this is a pyramid scheme. Unfortunately, this is how a lot of ICOs work. This is a problem, because then it just really means that this is a way for people to be able to cash out. And over time, the prices are going to keep on going up. So, for example, here's Ethereum, and you can see there was nothing happening for a long time. The price was pretty steady. Then all of a sudden, based on volume, the price jumps. Okay, so if I said this is to use my product, it's going to cost 10 Ether, that's their currency, then down here it might have been $10. Up here, that means that same product is now $3,000. So I have to reduce my cost, but if you watch how these things actually work, so there's a little variability. If I change it up here, and then you go down here, well, now people can buy it for much cheaper. So that means I have to keep on adjusting my prices. That's bad. Okay. And there's lots of different kinds of money. You have virtual currency up here, which is all purely electronic, not issued by a bank. You have local currency, so at the local farm co-op, they might have their own currency. That's only useful there. And then you have all kinds of other different kinds. You have cash in here. There's lots of different kinds of money. So this is something to think about when people are talking about ICOs and about virtual currency. So purely virtual currency is any currency not tied to something physical. If they've artificially limited the number, it's going to be a pyramid scheme in my mind. My Hulk coins was actually tied to something real. It was tied to a head of kale, and it also was going to age out. So you couldn't. Problem is that I had to age it out because otherwise someone could buy all of the coins or a large chunk of them, and then when people wanted to buy kale, they could up the price high enough to where no one actually ever bought any, and so I lose, and and my customers lose, and this person may have made some money, so that's bad. A lot of insurance is tied to something tangible, your house, your car. But then you have where a health company is trying to create coins just to reward behavior. That's not really tied to anything physical. It's tied to your health. That's kind of an intangible. Okay, so then we have this virtual health coin. So a health insurance company wants to reward you. So the patient, the doctor, and the insurer all come together and they say, here's the contract we're going to do. We go back to what's a smart contract. They make a smart contract. So they say, so this person says, I'm going to go to the gym, exercise a certain amount of time per week. So somehow the gym's going to be involved in this. Or they're going to have some way of monitoring whether I was exercising. I need to get at least 8 hours sleep a day, 5 minutes of walking every 2 hours between this time span, basically at work. If I'm doing this, then I get a cut in my premium because it's saving the insurer money. The doctor will sit there and say, and tell you what, we're going to make certain that we don't charge you we want to see you once a month and you don't pay anything. And for every 1% of body fat lost, I get some coins. And I can use these coins at certain restaurants. So I can go to Steak and Shake and I could reward myself with a shake. I can go to the gym and I can get a new shirt. They could have made deals with different people. And so these coins can be used. But the gym and the restaurant actually need to turn that into real money or convert to a different currency so they can actually buy things. So this is where you get into, you can convert from one virtual currency to another, or you can convert it to, they want it in gold, they want it in cash, or whatever. So that's kind of how that would work. Then we get into currency exchange rates. So some people will sit there and say, well, Ethereum is going to be the end all and be all. They're going to be the blockchain. The blockchain. I have a problem with that. It's like being the country. So basically, though, exchange rates vary. So the more of your money that goes out of your country into the international markets, the lower your money value is because the supply is higher than the demand. So if I buy something from France, well, I have to pay for it in their currency. So I have to use my money, convert it into their currency, and then, so now my money's out in the international market. So there's other things that can affect a currency rate, but import-exports is kind of an important part of that. If you don't import anything, if you're completely isolated, your currency is going to be, isn't really going to change much. There may not be much demand for it. If you don't import and export, people don't really need your money. So the demand is really low. So if you want to convert that, it might be much higher because they'll say, well, we can give you £1, but no one really wants your coin, so we need 20 of yours for that's £1 note. So that's kind of, so currency rates change a lot, but we have processes on knowing how to figure that out. So you have your coins. So like this is with Second Life Linden, I think is their coin. Just at one snapshot in time, what they exchange rates for it. And so what people would do is you could actually bid and sell. You just buy and sell, kind of like stocks. And so, but we would have where I've been buying these seats, I need to now do something else with that, because I might have been buying and selling the seats in, not in US dollars, but in some other currency. So now I need to convert that to dollars so I can go buy a new car. Okay, so there may end up being a blockchain where I can sit there and say, I have 20 of these, how much will people give me for it? Then they could have an auction, the highest bidder could get it, and that could actually be a smart contract. So we have a way to be able to figure out all of this. So some challenges with blockchains. It's new. We don't know what a decentralized economy is like. We had it long ago, 10,000 plus years ago. We had a decentralized economy. It's new territory for us. We don't really have it much in our books as to how's it going to work. And we're trying to design processes and tools and applications that will help to bring about, we're trying to create this decentralized economy. But how do you design something you've never experienced? So for example, we're going to get to the point where cars are talking to each other. When they're autonomous, they're going to have to. But so you could think about, if you're driving on the interstate, what kind of game can you play where you might only see this person for a minute or 5 minutes, or you're in a really bad accident, so you see him for 10 minutes, but people are going in and out of your game all the time. What kind of game are you going to have? Because you don't have a central server. You just have the cars communicating with each other. So the only people in your game are the people that you can communicate with. So the people in my part of the game are different than the car in front of me, or two cars in front of me, because they see some other people I don't see. So what kind of game could you have? And if you just think about, try to design a game like that. It's hard, because we don't have any frame of reference. This was basically just trying to give an idea as to, well, what is blockchain? And to be able to look more at, to be able to understand a lot of the terminology. So it was kind of a scattergun approach, but shotgun approach, I guess, to try and give a lot of terms. The next video is actually going to be more focused on just healthcare. We're going to be looking at, well, what's a decentralized healthcare system look like, and how can we get there? So, but I hope this was useful to you, and hope to see you start having a better understanding as you deal with all of the new ideas people are trying to come up with, saying, well, that's blockchain, because a lot of them really aren't. And have a wonderful day. Bye-bye.